A very good morning, dear students. In this video, I am going to teach you about equilibrium chapter. So, as we have very less time, it's very difficult to discuss about the complete chapter in 2 days. So, I am going to give you few important topics and questions based on that important topics. Okay. So, first we'll see what is degree of dissociation. So this degree of dissociation is also indicated by DOD. So there will be a chance to get a question from this degree of dissociation. So we have to know how to calculate degree of dissociation. So this degree of dissociation can be calculated formula, that is DOD is always equals to number of moles of dissociation, divided by total number of moles taken. So this is the formula to calculate degree of dissociation. Degree of dissociation is always equals to number of moles of dissociation from the total number of moles what we have taken for a reaction. Okay, so to calculate this, I am going to give you a table to understand very easily. See this table. If you know moles taken and moles dissociated, then you will get a degree of dissociation. So don't worry, these two will be given in the question itself, moles taken and moles dissociated. So by using these two, you want to find out this degree of dissociation. If suppose 1 mole of a substance or a compound is given and number of moles of dissociated if you consider as X, then the formula to calculate DOD is number of moles dissociated. What is number of moles dissociated? X, divided by total number of moles taken, that is 1. So then DOT becomes X by 1. This X by 1 becomes equals to now X. Okay. In the same manner, if 1 mole of substance is taken, in that 2X moles got dissociated. Just imagine 2X moles got dissociated, then 2X divided by 1 becomes equals to 2X. That is about the degree of dissociation. Okay, so next, if you take 2 moles of substance, in that if X moles of substance is got dissociated, then the total amount is degree of dissociation is said to be moles got dissociated X by 2. Okay, this is about the degree of dissociation. If suppose 2 moles of substance is taken, in that 2X moles got dissociated, then degree of dissociation becomes equals to moles dissociated divided by moles taken. So how many moles we have taken? 2X moles divided by moles taken is 2. 2 get cancelled and the degree of dissociation is said to be just X. Next, if you take A moles of substance, in that X got dissociated, then it becomes X by A. If A moles of substance is taken, in that AX moles got dissociated, then degree of dissociation becomes equals to moles dissociated divided by total number of moles, that is AX divided by A. A got cancelled and we will get X moles. That is about the degree of dissociation. If you remember this table, it becomes very easy to calculate a degree of dissociation for any type of reaction. Okay, so remember these two will be given in the question itself. You want to find out degree of dissociation. Okay, here I am going to tell you a trick, that is, okay, remember this trick to calculate degree of dissociation. Okay, just imagine if degree of dissociation given as X for a reaction, 1 mole of substance is got dissociated into X moles. 1 mole of a substance is got dissociated into X moles. Then 2 moles you want to find out. For 2 moles, how much it got dissociated? You just cross multiply it. That is 2X divided by 1, which is equals to 2X. That means 1 mole got dissociated into X, 2 moles got dissociated into 2X. For 3 moles, 3 into X divided by 1, 3X. For moles, 4 moles, 4 into X divided by 1, that is 4X. For A moles, A into X divided by 1, that is AX. Like that we will calculate about degree of dissociation. Okay, just imagine a question for this calculation. Before going to know that, so first we will come to know, if suppose degree of dissociation is asked in percentage. percentage of degree of dissociation is always equals to degree of dissociation into 100. That's it. Percentage of degree of dissociation is always equals to degree of dissociation into 100. So by using this formula you will get that. So if already percentage is given, you take this 100 this side, it divides. So percentage of dissociation divided by 100 can give degree of dissociation. Okay, it is a trick to calculate degree of dissociation based on percentage, or percentage of dissociation based on degree of dissociation. Now we will try to solve a question based on this. Here is the question, that is 2A moles of substance got dissociated into, got converted into 3B and C. So all are given in gaseous state. So at starting 3 moles of A are taken if degree of dissociation is X. You can see here degree of dissociation for A they have given, that is X. Calculate total moles of equilibrium. Okay, calculate total moles at equilibrium. Total moles we want to find out at equilibrium state. Okay, so first write down the reaction what they have given. 2A gives rise to 3B plus C. All are in gaseous state only. Okay, so first find out degree of dissociation at time equals to 0. That means reaction is not yet started. Then number of moles of this A is given. Number of moles of A is 3. You just write down 3. So before starting the reaction there is no formation of product. You may take number of moles of products as 0. Whenever the reaction reaches to equilibrium, okay, at that equilibrium we want to find out what is its number of moles. At equilibrium some amount of 3 moles of A is got dissociated. So that degree of dissociation I am writing here. Okay, so in the question again they have given if degree of dissociation is X. So this is for 1 mole. Okay, for 1 mole the degree of dissociation for A is given already for as X. But they have given here 3 moles. Then for 3 moles the degree of dissociation is what? You just do cross multiplication. Okay, then that is 3x by 1 which is equals to 3x. So this is degree of dissociation. 3x is degree of dissociation for this. That is from 3 moles 3x moles got dissociated. From 3 moles 3x got dissociated. Now we want to find out for this product and for this C. Okay, see from 2 moles how many moles of B is created from the equation? 3 moles. Okay, first write down this coefficients. Coefficients are nothing but the numbers present before that. Okay, here nothing is there which indicates 1. Write down that coefficients. I am writing here coefficients, that is 2 is giving to 3 moles of B and 1 mole of C. Okay, now for 2 moles, okay, for 2 moles this much got dissociated. For 2 moles this much got dissociated, that is 3x. Next, for 3 moles how much got dissociated? You just do cross multiplication again. Then 3x into 3 divided by 2 which is equals to 9x by 2. So 9x by 2 is the number of moles, moles got dissociated in this 3B. Okay, from this 2B. That is the value of this or got dissociated is 9x by 2. Next, for C we want to calculate. Okay, from 2 moles it is giving only 1 mole, right? Coefficient 2 is giving 1. For 2 moles amount of substance got dissociated is 3x, right here 3x. Then for 3x moles how much is got dissociated? Again cross multiplication, 3x by 2 or 3x into 1 by 2, that is 3x by 2. You just write that value here, 3x by 2. Are you clear? I think. Next, we want to find out what is the question. Calculate total moles of equilibrium. Total moles at equilibrium. Now write down total moles at equilibrium. It is equal. So you just add all the 3. Okay, 3, this is at equilibrium state. Add 3 minus 3x plus 9x by 2 plus This one also we have to add 3x plus 3x by 2. Okay, next 3 minus 3x plus this becomes 12x by 2. Okay, 2 ones are 2 6 are. 6s minus 3x is 3x. Then it becomes 3 plus 3x. This is the answer. The total moles at equilibrium state is 3 plus 3x. Like this we will calculate about degree of dissociation based on total moles at equilibrium based on degree of dissociation. Now we will see one more question. See the next question. So here they have given an equation. Initially 3 moles of A, number of moles is given, that is for A is 3, and 2 moles of B, number of moles of B is 2. Okay, so number of moles of A is 3, number of moles of B is 2 are taken. They have given 30% of A got dissociated. Percentage of degree of dissociation they have given at an equilibrium state. You want to find out the total number of moles. Okay, so here we have to use the formula, that is percentage of dissociation is equals to degree of dissociation into 100. As you don't know about this degree of dissociation, you want to find out from this. Then 30 divided by 100, degree of dissociation, percentage they have given 30. When it comes this side, it divides. 30 by 100 can give about degree of dissociation. So this value is 0.3%. That is degree of dissociation from the question. Directly they didn't give, they have mentioned percentage. From that its degree of dissociation has been taken as 0.3%. Now write down the equation to make easy. So this is the equation, that is 2a plus 3b gives rise to 4c plus 5d. Okay, so this is how it got converted. So at time time equals to 0, concentration of these number of moles they have given already. A is present in 3 moles, B is present in 2 moles, and these two didn't form because not yet the reaction is started. Next, at an equilibrium state, okay, we want to find out its number of moles. First, from this 3 we want to find out, okay, for 1 mole, just imagine, for 1 mole degree of dissociation we have calculated, that is 0.3. Okay, now total number of moles of A is taken 3. For 3 moles we have to cross multiply, that is 0.3 into 3, that is 0.9, that is for 3 moles. Okay, from 3 moles this much got dissociated, that is 0.9 at equilibrium. Next, for this you want to write down, so that you want to write the coefficients first. Coefficients are nothing but the numbers which are represented before that reactant or product. So what is the number represented here? 2, then 3, then it gives rise to 4 and 5. Okay, if suppose when 2 moles reacted with 3 moles, the number of moles got dissociated. We know for 2A, so 2A it is 0.9. You just write here for 0.9. It is got dissociated, cross multiplication, 3 into 0.9 divided by 2. Okay, so that is 2 ones are 2.15. Okay, you will get here 1.35. So that is amount of B got dissociated from 2 moles. From 2 moles. 2 minus 1.35. Okay, now we want to calculate for this. Either you may take this or this. It's not a problem. I am taking here 2. Okay, from 2 moles of A, 4 moles of C is got created. 2 gives rise to 4. Okay, so now we want to find out from 0.9 how many got dissociated. So 0.9 gives rise to question mark, cross multiplication again, that is 0.9 into 4 divided by 2, that is equals to 1.8. Okay, so the concentration here is said to be 1.8. Now for this one, even here I am taking from this only. Either this or this you may take, that's not a problem. I am taking here from 2, if it is giving 5 moles. From the dissociated molecule 0.9, how many dissociated molecules of D is created? Cross multiplication, that is 5 into 0.9 divided by 2. So the value is said to be 2.25. So here at equilibrium we will write 2.25. This is the major part what you want to do in the exam. If you know this, it becomes very easy to calculate this. Okay, 2.25. Then total number of moles at equilibrium. Total number of moles at equilibrium. Okay, that we want to find out. You just add all the three. So 3.0.9 is nothing but 2.1 plus 2 minus 1.35 is nothing but 0.65. I am directly subtracting, plus add this also 1.8 plus 2.25. Okay, by adding all this you will get total number of moles. You just do the calculation, and now I am writing directly total number of moles at equilibrium is equals to, after addition of all this you will get some 6.8 moles. Okay, this is about the total number of moles which are obtained at equilibrium state. So the major part is to knowing about the number of moles got dissociated. If you know that exactly, it's very easy to find out number of moles of at equilibrium state. So now we will see another most important part of this chapter, that is salt hydrolysis. We want to know what is meant by salt hydrolysis. Salt hydrolysis or hydrolysis is nothing but a reaction with water. Hydrolysis is nothing but reaction with water. Okay, so when salt is added by water, it leads to give hydrolysis reaction. So this hydrolysis, we may also say it is a reverse of neutralization reaction. Hydrolysis also we can say reverse of neutralization. What is neutralization? Acid plus base. When these two undergo reaction, they will give salt and releases water. Okay, whatever the products are obtained in neutralization, them only we are taking as reactants in the hydrolysis. That's why we can say hydrolysis is a reverse reaction of neutralization reaction. Now we'll see how to find salt hydrolysis for a given question. There are number of steps to follow and find out about salt hydrolysis. The first step or first trick is, you want to know what are the ions present in the water. Okay, when water is taken, this water is containing two ions, that is H plus and OH minus ion. If suppose a salt is added to water, just imagine AB salt is added to water. Okay, this AB can be converted into A plus B minus. You may also take A minus B plus, it's not a problem. Okay, so this salt is added to water. A plus is going to react with OH minus, H plus reacts with B minus, because they are oppositely charged. Okay, this cation is undergoing a reaction with OH minus of water, then this reaction is called cationic hydrolysis. Okay, this is called cationic hydrolysis. Now in this case, anion B minus, okay, B minus reacting with H plus, minus if is present, then that is said to be anion. Now anion reacting with the H plus part of water, then we will call it as anionic hydrolysis. It is called as anionic hydrolysis. Okay, that is about the first step to find out about the cationic hydrolysis and anionic hydrolysis. Next, step 2. In the second step, the Ha plus ion whatever is obtained or cation whatever is obtained, that when react with water, in water we know two ions are present. It grabs which ion? OH minus ion, because it has a plus. Then it converts into AOH. Okay, that water is still containing one more ion, that is H plus ion. Okay, in this case number of H plus ion concentration gets increases, then pH of the solution becomes less than 7. Okay, when B minus anion of salt is undergoing reaction with water. So due to having negative charge, it will abstract a proton from the H2O, then converts into HB or BH. If it grabs H plus ion, what is the another ion left over in the water? OH minus. Whenever OH minus ion concentration increases, automatically the pH of the solution becomes greater than 7. For this reaction, pH is becoming greater than 7. Here you want to remember that when A plus reacts with water, again it is giving cation. When anion reacts with water, again it is giving back anion. So that means A plus can give H plus ion, where concentration, ion, H plus ion concentration gets increases. Okay, when B minus reacts with water, it gives OH minus. That means OH minus ion concentration gets increases in this case. If suppose these two ions concentrations are equal, then that is equals to pH 7. If H plus ion concentration increases, then pH is less than 7. It is said to be acidic. It is said to be acidic. Whenever OH minus ion concentration increases than the 7, then the solution is said to be basic. Okay, that is the second one. And the third step is, so based on the different types of salts, we have to find out whether it is undergoing complete hydrolysis or not. Okay, here I am taking 3 different types of salts. First one, NH4Cl. Next one, NaCl. Another one is NH4Cl. Okay, just take the ions from which it is obtained. NH4Cl is a salt which is formed from NH4OH and HCl. Here NH4OH is a weak base. Remember that. HCl is a strong acid. HCl is a strong acid. Okay, in the same manner, NaCl is also made up of 2 ions or 2 salts. So Na is obtained from NaOH, Cl is obtained from HCl. Okay, so this NaOH is a strong base and HCl is also strong acid. NH4Cl, if you take, it can be ionized into NH4 plus Cl minus. If you don't know from where it is obtained, this is another method to find out whether it is from weak acid, weak base, or strong acid, strong base. Okay, whenever you add water to this NH4 plus, this NH4 plus will take OH minus and converts into NH4OH. So from this we will say it is a weak base. Okay, if you add H2O to the Cl minus, it can be converted into HCl, which is said to be a strong acid. That means if you don't know directly like this, you may also find from which type of acid or base it is obtained by adding water to the ions present in this case. Okay, here I am going to give you a chart to find out which is weak acid and which is weak base, strong acid and strong base. So this is about the list which belongs to weak acids and which belongs to weak base, strong acids and strong base. So if you remember this, it's very easy to find out whether the salt is obtained from weak acid, weak base, strong acid, strong base, weak acid, strong base, or weak base, strong acid. Okay, remember this table. This is very important to find whether the salt is from which type of ions. Okay, now the trick 4 or the step 4 is difference between the ionization and hydrolysis. Okay, difference between the ionization and hydrolysis. Okay, these two are not same types. Ionization is completely different from hydrolysis. We want to know what is ionization and what is hydrolysis. Okay, so ionization, for example, salt, if it is added by water, just imagine, if this salt is completely 100% ionized, okay, that means it is converted into ions, then that is said to be ionization. In ionization, only salt gets dissociated but not react with the water, that is called 100% ionized. For example, I am taking here NH4Cl salt. When it is taken in water, it can be dissociated into NH4 plus and Cl minus ions. That is dissociation. If suppose, or it is called ionization or 100% ionization. When it is added by water, so this NH4 plus is a weak base, then it can react with water. Whereas Cl minus, so the Cl minus is obtained from a strong acid, so it will not undergo hydrolysis. Okay, it completely ionized but not completely hydrolyzed. In the same manner, NaCl. From NaCl get two ions, Na plus and Cl minus ions. Na plus is obtained from a strong base, that is NaOH. Cl is also obtained from a strong acid, that is Cl minus. Because of obtaining both from the strong acid and strong bases, it will not undergo hydrolysis with water. They do not undergo hydrolysis. That means in water they completely ionized, or ionization will takes place but not the hydrolysis. Okay, so this is what you want to know about the difference between ionization and hydrolysis. In water, if any salt is giving 100% ions, that is undergoing ionization. If that ions are obtained from strong acids and strong bases, then they do not undergo hydrolysis, they just ionized. Next, trick 5 or step 5. In this fifth step, you want to find out whether the salt is made up of strong acid or strong base, weak acid or weak base. For example, a salt of strong acid and strong base is given. Okay, it won't undergo hydrolysis. It won't undergo hydrolysis. It will not take place hydrolysis because it is obtained from strong acid and strong base. And one more thing, if at least one strong acid or strong base is present, either strong acid or strong base, then also it don't undergo this hydrolysis process. That means strong acid and strong base. Example, we will take NaCl. So here pH of the solution is always equals to 7. It never changes to greater than 7 or less than 7 because it get dissociated or ionized but not undergoing hydrolysis. So pH of that solution is always maintained as 7 because it is made up of strong acid and strong base. Here I am taking few more examples. So here I am taking one of the example, that is ammonium chloride salt. This ammonium chloride salt is containing two ions, NH4 plus and Cl minus ions. Okay, so when it is dissolved in water, it can be dissociated into, it get hydrolyzed because it is obtained from a weak base. If suppose Cl minus is there, if it is taken in water, it do not undergo dissociation or hydrolysis. Okay, so it do not undergo hydrolysis. So here is said to be the concentration. We want to find out NH4 plus. When undergo hydrolysis, it can be converted into NH4OH plus H plus. Because it has positive charge, it will take negative part of the water. Okay, then H plus ion concentration is increasing, then pH is less than 7. At a time time equals to 0, concentration of this is said to be 0. These two are said to be zeros. But at equilibrium state, okay, some amount of the substance is got dissociated. So for example, when 1 mole is got dissociated into H, then C moles got dissociated into what? Just cross multiplication, CH. Okay, from CH amounts got dissociated and CH amounts are formed here and CH amounts of H plus is also formed here. Then the formula to find out about KH, that is dissociation constant for this hydrolysis, is indicated by KH, that is equals to a concentration of the products divided by concentration of reactants, right? Then CH into CH divided by C minus CH. We may also write it as C square H square by C minus CH. So C and common, I am taking H 1 minus H. Then C and square got cancelled. So then KH becomes equals to CH square divided by 1 minus H. Okay. But at dilute solutions, this is almost equals to 1. Then we will neglect this. Then KH becomes CH square. KH becomes CH square. Okay, then from this you want to find out what is H value. Okay, then H becomes equals to square root of KH divided by C. So this KH can be calculated. This will not be given in the question. It will be calculated by using a formula Kw by Kb. This is nothing but dissociation constant for a weak base, because it is obtained from a weak base. It is from strong acid. We want to take that weak base. So from that weak base, this KH value can be calculated. So then if you substitute this KH here, you will calculate about H value. If you know H value, C is nothing but concentration of the solution will be given in the question. Then concentration of H plus ions becomes equals to CH. Okay, you know H and you know the concentration of solution. By multiplying these two, you will get the value. Then finally, pH of the solution is equals to minus log concentration of H plus ions. So from this, you will calculate pH value for this given ion. So first you want to know what is the salt type, whether it is weak acid, it is from weak acid, strong base, strong acid or weak base. Now I am taking one more, that is CH3COONA. CH3COONA. So the CH3COONA can dissociate and give two ions, that is CH3COO minus and H plus. CH3COO minus, not H plus, Na plus. Okay, so when it is dissolved in water, it can undergo hydrolysis because it is obtained from a weak acid, that is CH3COOH. I have given a list, from that you can check. Na, when is added by H2O, it do not undergo hydrolysis because it is from a strong acid. Then take only weak acid, that is, sorry, it is from weak base, CH3COO minus, when it is added by H2O, it converts to CH3COOH plus OH minus. At time equals to 0, concentration of this is C and these two becomes 0. But at equilibrium state, some amount got dissociated, right? Then C minus CH we will take, and concentration becomes CH for COOH, and for OH minus is also CH. Then KH value for this, I am not deriving finally because both are containing the same values. Then finally KH is what? CH square. Okay, H becomes equals to square root of K into or KH divided by C. Okay, this is the formula to find out this H value. Then KH value is calculated by using one more formula, that is Kw divided by, here it is taking weak acid. This is weak acid. So you have to divide it with dissociation constant of weak acid. Then you will get KH, substitute here and you will get the H value. If you know H value, from that we will calculate OH minus ion concentration. OH minus equals to HC. Concentration of OH minus, because it is releasing OH minus, concentration of OH minus becomes equals to HC. So then I am writing here, okay, POH we want to find out because we have OH ion concentration which is equals to minus log OH minus ion concentration. Okay, then finally from that you will get pH value. pH becomes equals to 14 minus POH. 14 minus POH. This is pH finally what we want to find out. So this can be obtained from POH because in the equation OH minus ions are released. So first we want to find out POH, then we want to find out pH. If suppose pKa becomes equals to pKb, then pH value is equals to 7. If pKa is greater than pKb, you have to remember this relationship. Then pH is less than 7, greater than 7. When pKa is greater than pKb, then pH value becomes less than 7. You just remember this relationship. Okay, so finally till here it is enough. This is the final formula what you want to remember to calculate pH from POH for this weak acid and strong base salt. Okay, this is how to find out about the salt hydrolysis of a reaction. So questions based on this we will discuss tomorrow, and even you can try the question or solve the question based on this tricks whatever given today.